Thank you. So in the previous sessions, right? Okay, if we just give once a review of what we have discussed till now. So like what is big data, Hadoop, drawbacks of databases, Hadoop advantages, components, right? So mainly like Hadoop doesn't use any databases for storing its data. Databases has got some drawbacks. Despite of these drawbacks, Hadoops go with a special kind of file system called Hadoop distributed file system, right? So most of the databases doesn't perform parallel processing. If volume increasing, speed decreases, complexity increases, speed decreases, and databases can handle only structured data. They cannot handle unstructured or semi-structured data, right? And Hadoop mainly used for batch applications, means like millions and trillions of records, right? For user non-interactive applications, means where user involvement is not required. And here online applications means user involvement required. Okay, user interactive applications we call them. And Hadoop doesn't follow like client server request response architecture or client server architecture. It follows master slave, single master, multiple slaves architecture, right? And there are two types of nodes, master and slave nodes, right? Master nodes assigns tasks, load balancing, fault tolerance, means in the absence, suddenly if any node or slave gets failed, right? And the task of it is going to be assigned to any of the other slave. That is what fault tolerance mechanism, health monitoring, right? Okay. Slave node responsibilities for storing and processing the data, executing the task, right? Processing the data and storing the data. So Hadoop main advantages that what we see, right? Unlimited data storage, huge data storage, like because of horizontally unlimited scalability, means horizontally unlimited number of slaves can be added. Horizontally unlimited number of slaves can be added. There is no limit for the number of slaves that Hadoop can have, right? So we can go with any number of slaves. That's why Hadoop, if we talk about the applications, observe, I was just saying that if you observe, one second, I'll come back to it. Very high speed processing in Hadoop because of parallel processing, whether a job divided into tasks are distributed across multiple slaves executing parallelly, working on a single job. Very high speed you are going to achieve, right? Open source, Hadoop is an open source, no licensing required. Most of the Hadoop products we are going to take from Apache Mirror's website. Okay, can handle all varieties of data. Hadoop can handle all varieties of data, like structured, unstructured, and semi-structured, right? Okay. So for example, a processing point of view, I was just saying, right? Yahoo has conducted a test to check the speed of various databases, right? By taking a table of 100 TB consisting of 1024 columns. Sorting based on 16 columns. If we talk like the databases, like that's Oracle taken 3.5 days, SQL like 6 days, Teradata like 4.5 hours, Netija just 3 hours, right? Okay. Hadoop has just taken 3.4 minutes, right? And why databases like Oracle won't support unlimited storage? Why databases like Oracle won't support? Means there is a limit on the number of slaves that these databases can have. Like Oracle, all these databases, most of the databases goes with 256 slave nodes. Behind that, they are not supported, right? And even if we talk about the specialized databases which are used for data warehouse purpose, like Teradata, Netija, Vertica, currently they are going with 1024 slave nodes, right? But still they are not unlimited. Storage is not possible. We talk like previously, like Yahoo, when first time implemented Hadoop, went with 4,000 slaves for storing its data, and currently going with 12,000 slaves. Facebook, first time it has implemented Hadoop, went with 8,000 slaves, currently going with 42,000 slaves for storing its data, right? And Hadoop Echo, what are the components that we discussed? Like mostly like processing components like MapReduce, Pig, Hive, and Spark, and one storage like HDFS, and Scoop is for import and export, and one NoSQL database like NoSQL Express, and to like Fluent, Kafka, like streaming data and technologies we are going to discuss. And Spark in brief, like Spark as part of the course will be discussing like 50 to 60 hours on Spark, right? With Spark Scala programming. Spark is an execution model implementing in Scala language. Spark Core, Spark SQL, Spark Streaming, right? RTD's concept in Spark Core, data frame concepts in Spark SQL, data DS streams in Spark Streaming, right? In brief, we'll be discussing with multiple uh, inbuilt, like what are the actions, transformations provided by Spark. No need to write huge codings, and even from data frame APIs for performing. Okay, fine. Zookeeper controls and coordinates. So these things, everything I'm going to discuss in brief, right? Okay. So we'll be getting in-depth knowledge on all these components. Fine. And just you need to know how exactly data is stored in Hadoop and how data is going to be processed in Hadoop, right? In Hadoop, data is stored in the form of files. File is again subdivided into blocks. So file is subdivided into blocks. Default block size 64 MB. Like the current latest versions, like the default block size 128 MB means if you talk any file, it is divided into this fixed size chunks called as blocks. It is divided into smaller parts. So divided into smaller parts, they are going to get distributed across the multiple slave machines, right? And are processed parallelly, because of which Hadoop is going to achieve huge speed, high speed, right? And design principles with respect to HDFS block means in a single, okay, every file will have dedicated number of blocks. In a single block, you cannot store two files data, right? Tomorrow, like if you want to retrieve a particular file, only that file data you are going to retrieve, right? So in a single block, no two files data to be stored. All blocks have equal value except the last block, right? So how to configure the block size? By default, it is 64 or 128 MB, but even we can set the block size, that go to the Hadoop installed directory, Hadoop etc conf hdfs-site.xml. By default, it is an empty file, right? It's an empty file. You need to just configure some, okay, this way. Okay. So configuration property, one property, what is that property name? dfs.block size, block dot size, dfs.block dot size, sorry. dfs.block dot size, 50 M or 100 M or 150 M, how much? Replication, I was just discussing about replication and fault tolerance. Duplication, you can have replications in Hadoop, right? Default number of replications, replicas are 3. We can configure, increase or decrease the replications. Okay. So if the data is very sensitive, then we are going to go with more number of replications. Yes. Yeah, 1 second. Some of them facing problem with this. Give me a second. 1 second. Yeah. default number of replications is 3, right? We can increase or decrease the replications, right? Okay. Fine. If the data is a very sensitive data, then we will go with more number of replications. But if it is normal data, so we can increase or decrease, or we can configure the replications I said, right? Okay, I'll just show you. Okay. So in the last, we have discussed like replication, right? And replication and fault tolerance. For example, if I take a file f1.txt, any file, right? Size 192 MB, right? Number of blocks into how many blocks? Just divide into how many blocks? File size by default block size. Default block size, right? Whatever it is. The file size is 192. Assume default block size, whatever you are taking. If you're taking like 64, like 3 blocks, you are going to see like 3 blocks, right? A file, I'm taking a smaller file, divided into blocks. Okay, B1, B2, B3. B1, B2, and B3. B1 replicated by 3 times, B2 by 3 times, B3 by 3 times. Totally you are getting 9 blocks, right? 9 blocks. How these 9 blocks are going to be stored across the cluster? Say master and slaves, right? Think that you have got 3 slaves. If more slaves, more parallelism, more speed. If less slaves, less speed. If only one slave or no parallel processing. Okay. Slave 1, slave 2, and slave 3, right? So here B1, B2, B3. How these 9 blocks going to be stored across the 3 slaves, right? B1, B2, B3, again like B1, B3, B2, again B3, B1, B2, right? Okay, 9 blocks, they are just accommodated within these 3 slaves. Okay. So here a file name master node of this stores the metadata information, metadata, data about data. f1.txt, it is divided into 3 blocks, B1, B2, and B3. And B1 stored across this S1, S2, and S3. B2 also distributed across S1, S2, and S3. B3 also S1, S2, and S3, right? Okay, fine. So here, 3 blocks, actually what 3 blocks? If you are dividing the file, if yes, one more time, let's not write. 192 is the file size by 64 is the default block size of Hadoop. Means a file is divided into fixed size blocks of size 64 MB or 128 or whatever you are setting, right? Default block size. Think that if it is 64, it is 64 MB block, 64 into 3 blocks. But later what I did, replication, replicated by 3 times, B1 by 3 times, B2 by 3 times, B3 by 3. B1, 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 B2, 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 B3, 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 right? So totally 9 blocks, right? 9 blocks. How these 9 blocks are going to be stored across these 3 slaves? 9 blocks means B1, B2, B3, B1, B2, B3, B1, B2, B3 means. So first set of B1, B2, B3 in S1, second set of B1, B2, B3 here, third set of B1, B2, B3 here. Understand? So I mean to say this B1 is replicated for 3 times. So the B1 stored in S1, S2, S3. Similarly, B2 also stored in S1, S2, S3. B3 also in S1, S2, S3. I'm storing this blocks in multiple slaves. Understood now how this is stored, how this is distributed. If I got some 10 slaves, right? This 9 blocks can be stored across this. In each slave, one block can be stored. If you have got more number of slaves. 9 slaves are available. All these 9 blocks you can store across this 9. But here only 3, right? Understood.
So I have a doubt, sir.
Yes, go ahead.
So in case if now you have mentioned that if you have a 10 slaves, then 9 slaves, then you will be saving each block in one slave, right? So we don't have any hard criteria that only these number of blocks have to be saved in each slave.
No. So it depends upon your cluster capacity, right? Number of slaves. For example, 1 second. I got 10 slaves available. My blocks are 40 blocks are available. 40 blocks, 10 slaves. Means in each slave, how many blocks? Approximately like 10 blocks are stored. There are 10 blocks. If I got only 5 slaves, in each slave, 20 blocks are going to be stored. 20 blocks. If I got only one slave, all the 40 blocks stored in the same one slave only. In that case, no parallel processing is going to happen, right? Only that single slave need to process all the blocks data. So if 40 slaves are there, 40 systems, 40 slaves are there, in each S1, 1 block, in S2, B2, in S40, B40, right? So it depends. So here, if 40 slaves, 40 blocks means 40 tasks. Means these 40 tasks are executed parallelly by 40 slave systems, full speed, high speed. But if you have got only 20 slaves, right? Means first 20 tasks executes by the 20 slaves. The remaining 21 to 40 tasks will be in the waiting state, right? Understanding. 21 to 40 will be in the waiting state. Okay. Same way, your distribution of the blocks depends upon your slaves, right? How they are going to be stored across this. Fine. For example, I got okay, 1 second. Two slaves, 9 blocks. In slave 1, how many blocks? 5. In slave 2, 4. Right? 2 slaves. But if you have got 9 slaves, 9 blocks, in each slave, 1 block will be stored. 1 block will be stored. So, now, data processing. Now, if you observe this data processing, right? Job is to process this f1.txt. Generally in Hadoop, number of tasks always depends on number of unique blocks. Number of unique blocks, right? How many unique blocks here? How many unique blocks?
3.
3 only, right? 9 are duplicated blocks. 6 remaining 6 are duplicated blocks. So number of tasks all depends on number of blocks, T1, T2, and T3. Right? So job is to process f1.txt. Yes. So divided into 3 tasks, T1, T2, and T3. Right? T1 task is for executing which block? T1 task is for executing which block?
B1.
B1. T2 task is for executing B2, right?
Mm.
T3 task is for executing B3. Here T1 task should be executed by whom? T1 is for executing B1. B1 present in S1, B1 present in S2, B1 present in S3 also, right? T1 for executing, okay. S1 can execute, S2 can execute, S3 can execute. All these 3 slaves can execute this T1 task for executing B1 block, right? All these 3. Similarly, here also like S1, S2, S3, 3 slaves. S1, S2, S3. These 3 slaves can execute this T2 task, that is B2 block. And here also S1, S2, S3, S1, S2, and S3. So any of this. So my master node can select any one slave from this. So for executing T1 task, assume that S1 only selected. For executing T2 task, think that S2 only selected. For executing this T3 task, S3 only selected. Assume. Okay. Yeah. Preview. Yeah, preview. For example, I'm taking, if you have got this one master and multiple slaves, right? For example, if you have got n node cluster, right? If you have got n node cluster, n minus 1 slaves, one master. 40 node cluster, 39 slaves, one master, right? Okay, here for example, I've taken a small cluster. I'm just explaining. So here T1 task executed by S1, T2 by S2, T3 by S3. 3 tasks T1, T2, T3 executed by 3 slaves S1, S2, S3. Assume as multiple slaves are executing parallelly and multiple tasks are executed by multiple slaves parallelly, right? Suddenly, if any slave machine goes down, as they are machines, if any machine goes down, do you think there is any data loss? Do you think there is any data loss here? As there is duplication, right? So still this B1, B2, B3, B1, B2, B3. T2 task is for executing B2 block, right? Still that B2 available in T1 and B2 available in T3, that's S3, sorry. There is no data loss. Still the blocks are available in the other slave machines. So still we can make those slaves to execute the T2 task, right? So here the task T2 can be assigned any of the other slaves like S1 or S3, right? When multiple tasks are executed parallelly. What do you mean by, one second, here I write. What do you mean by fault tolerance mechanism? Yes. What is fault tolerance? When multiple tasks, assume like T1, T2, T3, T1, T2, T3, when multiple tasks are executed by multiple slaves. S1, S2, S3. If suddenly any slave goes down, then the task of that slave is allocated to any of the available slaves. This process is called as fault tolerance mechanism. Fault tolerance mechanism, right? Okay. So here, three tasks T1, T2, T3. T1, T2, T3 are executed by three slaves. Suddenly, if S2 down, then the task T2 can be assigned to the other, like S1 or S3. Okay? This is called as fault tolerance mechanism and replication and fault. Here I got some couple of queries here. You may ask, right, why when S1, S2, S3 are eligible, are they able to execute the T1 task? Why S1 only given the priority? When three slaves can execute the T1 task, why S1 only has given the S1 for S1 only? Why that? What criteria is followed in allocating the tasks? That is one. If the slave to S2 is down, the T2 task will be assigned to T1 or S1 or S3. What criteria is followed in allocating the task to T2 to S1 or S3, right?
Sir, first come, first serve on basis.
Okay. Not like first. So here, slave 1 is there. Slave 1 is slave 2, slave 3. 3 slaves. S1 executing T1 task, S2 executing T2 task, S3 executing T3 task. They're running in parallel. Suddenly S2 down, slave 2 is down. T2 task assigned to which? S1 or S3? S1 or S3? This is what my query. So here, first criteria. Here we got 4 steps criteria. Here, here 4 steps criteria is followed. First one, master node selects the slave which is highly configured. master node selects the slave which is highly configured, which has got high configuration, right, between S1 and S3. If both has got, if both are highly configured, think that if S3 has got highly configured, then the task T2 will be assigned to S3. If S1 is highly configured, then the T2 task will be assigned to S1. If both are highly configured, then second step, name node, master node selects the slave which is more ideal. The slave which is more ideal and free. Selects the slave which is more ideal or free. Among S1 and S3, which is more ideal or more free? Assume if both are free. So if S1 is free, then it will be assigned to S1. If S3 is free, it will be assigned to S3. If both are free, then assume. So our situation. Master node selects nearest to it, which is nearest to it. Master node selects the slave which is nearest to it, right? Assume if all the master and slaves are at the same place, if both are equally near, if both are equally near, in that case, master node selects the slave which has good health status, right? Master node selects the slave which has a good health status, right? Which has got a good health status. Right. Okay. If both has got good health status, then in the extreme case, it selects any one slave randomly. So this is the internal criteria followed in selecting the slave, either whether any slave is down or while allocating the task to if any multiple slaves are eligible for executing a task, which slave will be given the first priority. Generally, if I take a labor example, if three students, a person with 90%, a person with 80, one person with 70%. If any task comes, which task need to be allocated to which student? First preference will be given to the person with 90%, right? Which has got a good percentage, right? In the same way. If all has got same percentage, in that case, again, we'll go with the second criteria, third criteria, right? We'll see the other conditions. Here also, that's 4 steps criteria is to be followed, right? Fine. While allocating the task. And here in the previously, I was saying, right? Configuring block size and replication. Default block size by default 164 and 128 MB, depending upon the version set. But even I can just set a property dfs.block.size. Okay, some 50 MB or 100 MB or 150 MB, right? So I was just briefing you, right? Having block size, very small block sizes advantages, or very larger block size, having very large block sizes. Which one is advantageous? having bigger block size or smaller block size?
Both.
I'm saying you can keep your own block size. By default, it is 64 MB or 128 MB. Means your Hadoop file divided into this fixed size blocks. By default, you can have 64 128 as a block size, but you can keep your own block size. I'm saying. So, what if it is 128 MB in the latest versions? Whether you want to keep less than it or more than that. If you are saying like I want to configure, I want to have my own block size. What is the answer?
I
So we
think having
can go
more.
with 128 MB because if block size is more, then it will take time to process it, and if block size is less, then while extracting data,
For
it will take
example, okay, for example, as I got that option to change the block size and then keep my own block size, default block size, I'm configuring to, instead of 128 MB, I'm configuring to 500 MB. Keeping this 500 MB is advantageous or drawback?
it's drawback because one slave will occupy for that 500 MB. If I have nine slaves and I have file with 1 GB and I convert it in two blocks with 500 and 500 MB, then
So,
other block
exactly. So if you have got a file of 900 MB, right? If you have got a file of 900 MB, right? If it is 500 MB, it will be divided into two blocks, B1, B2 only. B1 of 500 MB, B2 of 400 MB, right? This B1 stored here, B2 stored here. Only two slaves are working parallelly and executing that particular file, right? Even though you got 40 slaves available, you are just performing only two slaves parallel. So very less speed, right? You are going to see very less speed. So in that case, if you keep less block size like 50 MB or 100 MB, right? 100 MB means in 9 slaves can be 9 slaves can work parallelly. If you are giving 50 MB, right? 18 slaves can work parallelly on this, right? And what if I give this default block size as, if I give very small block size like 5 MB? Is it advantageous or drawback? 5 MB 5. Default block size of 5 MB, is it advantageous or it's a drawback? Okay, for example, same 900 MB file is there. How many blocks you are going to get? Five MB means
180 blocks.
How many?
180 blocks, sir.
180 blocks. 180, a small size, a file, 180 blocks. 180 blocks are distributed across multiple slaves. Tomorrow, if I want to retrieve it,
it will take time.
180 blocks retrieving. It's for a small file, right? Splitting, distributing across multiple slaves, again combining and retrieving them is it's a time-based process, right? So if the block size is too small, it's a time taking. If too big, less parallel processing, less speed you are going to achieve. So that's the reason Hadoop has kept a block size of 128 MB, right? It's not too less, too more. So your file is going to be divided into fixed size blocks. Okay, fine. Now observe. For example, I've changed the block size. You know how to change this block size, right? This is the step. This property, this 3 lines property we need to write for changing this block size. Okay. So after changing this block size or replication, right? Okay. Here I'm writing a note. Here I'm writing a note. This is important. 1 second. Give me a second. 1 second. Okay. Fine. So just observe whenever you are changing the block size and replication, right? Okay. Whenever we configure the block size or replication, block size and replication, right? And replication. We need to restart the cluster. We need to restart the cluster. Else the changes won't be applied. Otherwise because only at the start of the cluster, only at the start of the cluster, the configuration file is read. Okay. So if you are not changing it, it will just the previous changes only will be reflected, right? Okay. We need to restart the cluster, otherwise the changes won't be. Okay. Now observe. January 2021, right? January 2021, I got a file f1.txt. Okay. So the default block size was 64 MB. Means the file is divided into 64 MB blocks and stored across the slaves. In February 2021, right? I got a file f2.txt, and here also the default block size is 64 MB only. Okay, but in the March 2021, like I got f3.txt file. But I changed the default block size. I changed the default block size to 128 MB, 128 MB, right? So the default block size it is going to consider is F 128 MB. In March, if I execute f1.txt, what is the block size taken? In March, if I execute f1.txt, what is the block size taken? What is your answer?
Sir, 128.
Is it 128 or 64?
If cluster is get restarted, then 128, else 64 MB.
Compulsory. Okay, whenever we modify anything, the cluster will be restarted. Yes, it is restarted. Okay, now you say
128, sir.
yeah. Observe. So what is the block size it is taken is yes. Everyone try to answer this.
128, sir.
It takes 64 MB only, right? In the month of January, already f1.txt, it is divided into smaller quants with 65 MB chunks, right? Already it's stored across the slaves. f2.txt also, it was stored across the slaves, right? Again in March, you are not going to split it again. You are not going to store it once again, right? Already it got stored. Just you are going to process it. So this f1.txt stored across how many slaves? Think that it has stored across some 5 slaves. Those 5 slaves are going to execute parallelly. Already they have got stored across 5 slaves in January month. So the same 5 slaves will be executing it parallelly. f2.txt also was stored across in the month of February. Again, we are not going to split, and again we are not going to store it with 128 MB blocks, right? So what is your observation here? All the old files are going to take the old block size. All the new files which are coming, okay, will be taking the new block size. Understood, everyone? So here the old files will have the old block size. New files are going to take the new block size, right? Okay. Fine. And one more query. I got one more query. Yes, I got slaves like this. Is it mandatory that all the slaves should have the same hardware configuration? Is it compulsory that all the slaves need to have the same hardware configuration, or they can have different hardware configuration? For example, you are running, your data is increased, your customers have increased, customers are increased, data is increased, your branches have increased. You cannot go with the same number of slave types. You will go with the, you are increasing the number of slaves. Last year you got 20 slaves. This year 20 more slaves were added, right? So doesn't mean that you need to go with the old, you are going with the new configured, highly configured systems, right? So the slaves can have different configurations, not a problem, not a problem, right? And one more query, S1, S2, S3, all the slaves need to have the same default block size? Once again, can anyone please confirm whether my voice is clear or is it very low? Yeah, can
Clear,
anyone,
sir.
is it clear?
Yes, sir.
Is it very low or it's fine?
No, it is fine, sir.
Okay, fine. Thank you. See here, is it mandatory that all the slaves need to have the same default block size, or S1 can go with one block size, S2 can go with one default block size, S3 can go with one default block size?
No. Default block size, sir.
all the slaves need to have the same default block size. It's recommended, right? We cannot go with a different block size for different slaves. Means if you are dividing a file into fixed size blocks, right? For example, I'm dividing a file into 128 MB blocks. 128 MB blocks. But here S1 has got 64, S2 has got 128, S3 has got 64. But this 128 MB blocks cannot be accommodated in S1 as it has got 64 MB blocks. Okay, so default block size should be same for all the slaves, right? Fine. So in the tomorrow session, just I'll be discussing about the architecture, Hadoop architecture, storage architectural components, processing architectural components, storage architecture and processing architecture, especially in storage and processing, what happens internally in the storage part, like we have got. See, one thing I was just asking a query, right? If a slave is down, we have got this fault tolerance mechanism that a task is done by any one of the other slave. But if master is down, if master node is down, right, the entire cluster will be down. Just like if the king is down, right? Just like if the master is down, you cannot perform any storage and processing operations. So the connections between all the master and slaves will be declined, and everything will be in total cluster will be down. So in such case, so here these are data nodes. This is name node. This is name node, right? These are data node 1, data node 2, data node 3. We call it as. If a name node is down, right, we go with secondary name node. So if name node is down, we go with secondary name node, right? So if name node is down, just like in the absence of the principal, we go with vice principal, right? In the absence of the name node, master node, we have got secondary name node. So I'll be just briefing you about those things in the tomorrow session. Name node, data node, secondary name node, that is storage architectural components and processing architectural components. How exactly, just I said in a generalized way, right? Now internally what happens, so how this processing is going to happen, who is going to assign the task, who is going to execute the task, who is going to take care about the fault tolerance in the absence of if any slave goes down, right? Okay, fine. Yeah. So from Hadoop 0 version, Hadoop 1 version, Hadoop 2 version, Hadoop very recently we have got like Hadoop 3 version, right? From Hadoop 2 version onwards, we have got a lot of architectural changes. I'll be discussing that. So as part of our course, I'll be discussing the versions Hadoop 2 and 3 versions, right? So 2 version and 3 versions. Yeah. 0 and 1 versions are the previous old versions, but they have got some drawback that everything got rectified from Hadoop 2 version onwards, right? Fine. And so as I said, both. Yeah, at the end of the course, I'll be discussing one flow, total flow, project flow, right? How this flow is going between these different components, right? So I said in brief knowledge on this total Hadoop and Spark. So actually previously it was Hadoop and Spark, 2 different courses. It used to go, but now combined it together, we are providing you with the same constraint with the list. Okay, Hadoop and Spark. I'm going to like 45 to 50 hours on Hadoop and nearly 50 hours on Spark, like totally like 2 to 2.5 months. I'll be covering these things, right? 2.5 months on both Hadoop and Spark in brief. So more discussion in Hadoop also. I'll be discussing more on this Hive component like data warehouse.
Sir, will you going to cover some topics of PySpark? And
see one thing, Spark with SCALA implementation. SCALA is one language, just like how to define in Python. So I've got separate batches for PySpark. I'm running separate batches for Spark with Python implementation, PySpark batches people to go. But as part of this Hadoop and Spark, we'll go with SCALA. But the thing is, only the programming is going to change. How you define a variable in SCALA, how you define in Python. How you define a function in Scala, how you define a function in Python. Only that is going to be changed, but the total Spark related things will be as it is. They are not going to be changed. All the inbuilt APIs of Spark will be same in any language. If you're implementing in Scala or in Python or in Java, right? The Spark APIs, the inbuilt features, everything going to, but only the programming coding is going small, like how to define variables, functions, the other things. And in PySpark, we have got some changes, like we have got the concept of modules, right? Okay. So here at the end of the course, I'll be discussing after I complete, right? I'm going to give you some knowledge on this PySpark also, right? Yes. 2 weekends, like 1 or 2 weekends, I'll be spending on the PySpark, right?
It will cover all the topics of PySpark mostly.
So Spark, everything I'm going to cover, right? But how to implement those things in Python also, I'll be just guiding you, right? But here total my concentration, why? Because Spark by default built by using Scala language.
Okay.
Spark by default built by using Scala and Python mostly used, but I'll be giving mostly my concentration will be on Scala, but at the last, but for PySpark, I got separate batches. And as you are preferring this, right? At the end, I'll also give knowledge on PySpark. That means how that implementations within the PySpark also, right? Okay. Anyhow, you'll have that entire knowledge on Spark, right? Anyhow, you'll have the entire Spark knowledge. How you are implementing in Scala, you are coding in Scala, how to code in Python also. Just
Sir, is this weekend batch or daily batch?
any more queries? And one more thing, tomorrow, regular batch, right? Daily from Monday to Friday, you'll be having the sessions, right? 6 o'clock to 7 o'clock.
Okay. And if I miss any batch or any dip, session, then the recording will be provided, right?
Yeah, every day you'll be getting the recorded. Every session is video recorded. You'll be getting that video, right?
Okay.
So once you get enrolled, right? Once people get enrolled, you'll be getting a Google Drive link. You'll be getting into that link. Every day one video will be uploaded.
Okay.
You can just check it.
What is the validity of that video? How many days we can access?
Yeah, that video access will be there once you complete the course. After the course, 6 months you can make use of it. After the course completion, right? You can make use, means you can just check that videos for 6 more, that is months, 6 more months. 6 months access will be given.
Okay, one more thing, sir. Will you going to teach Hadoop on cloud? Little bit of knowledge.
Yeah, at the last I'll be providing that also, right?
Okay. Thank you.
So, in depth statement by statement, line by line, the explanation, and clear notes also will be given. You'll be getting notes to your mail IDs. To your mails, okay. The notes will be forwarded, right? And as said by this online team, we have got like DURGASOFT online team. They will be taking care about that, forwarding the videos, all these things. But notes I'll be forwarding directly to your mails. And later for our technical discussions, other interactions, we'll have a, what is that group, WhatsApp group will be there for technical discussions, other discussions with those who have got enrolled. And tomorrow, as said, right, by that online team, already we have got sessions, previous sessions, right? Tomorrow the link is going to be changed. Tomorrow's session means only those who have got enrolled or those who have got registered course, right, will be getting that link to their mail IDs. Okay, so just enroll with those things. If you want, you can check that previous sessions. If anyone are absent for the previous sessions, you can just say Hadoop by Mr. Vijay DURGASOFT, right? Hadoop by Mr. Vijay, and you can check the previous sessions videos, right? We have got introductory session videos.
Right?
Okay. So tomorrow will be
available on YouTube.
Yeah, YouTube channel is available, right? The previous videos, introductory videos, right?
Google Drive link will that new link.
No, Google Drive link only the first 4 sessions you can see in the YouTube, right? Remaining all only for those who have got enrolled, you'll be getting the Google Drive link, not all this.
And this new link will come on my our email.
Yeah, the new link, the changed link you will be getting to the to your mail IDs. To your mail ID. And If anyone facing any problem or any issue, that you can just have a note of this online team, right? There, so you can take the number of this online team if you have got any issue or problem. Already, I think you have got some mails to your, right? One second. Yes, this is that. You can contact this, right? One more. So these two numbers you can take, right? These are the contact details of this online team. If you face any problem with the links or videos, you can just, okay. Tomorrow there will be a change in the link. So get registered and enrolled before we discuss. Tomorrow I'll be discussing Hadoop architecture, like storage architecture and processing architecture, right? Fine. So I'm stopping here for today and meet you tomorrow, same time at 6 o'clock, right? Fine. Thank you all. Thank you all for your time.
Sir, what is the fee structure for PySpark that you're talking about, other batch you're taking?
So it depends, right? This is an offer batch, right? There will be some offer batches will be there, some will be normal batches are there, right? So batch to batch it will be differing, right? So it was offer, it was like 7K for that, 7K for this PySpark, right? Just running.
Okay.
So for this current Hadoop and Spark, it is 10K, right? It is an offer batch which is given for only 10K, right? Fine.
Sir, you told that we already have a class at 5 o'clock, right?
Yes.
5 or 5:30. So in that, are you going to cover PySpark? I mean, Spark with Python more, or else it would be the same syllabus?
No. PySpark batches will be in the weekends, right? Not regular batches. PySpark batches will be running in weekends, Saturday, Sunday, 3 hours will be.
Okay. So what is the duration for that batch, sir?
8 weekends, 2 months, 8 weekends.
Do we have any class right now or else in the upcoming?
For PySpark you are talking?
Yes.
Oh. As of now, I need to check it. As of now, you don't have. After 20 days, I think it might be starting with that. But as of now, there is no. So.
Okay, sir, just one request is there. Whenever you start a new batch, please inform us, because in last month in Tech Mahindra interview, they asked me for PySpark.
Yes. Fine.
Okay.
Yeah. PySpark. Okay, fine. Okay, fine.
Yeah, and if possible, can you cover more on PySpark in this class also?
Yeah. Anyhow, you'll be my total focus will be on Spark only. Spark.
Because whenever I saw in interviews, right, like most of the people now, especially, people are saying that SCALA is becoming like old. Everyone is interested only in Python. So most of the interviews they'll be asking regarding Python only. Spark with Python.
Okay. Fine. Okay, fine. I'll cover it. Not a problem. I'll just take care on both the things, both the languages. I'll be just differentiating. Right. Fine. You can parallelly just implement in both the languages, right? Fine.
Thank you.